Hi guys, you need to pause the video and solve the warm-up. Once you're finished solving the warm-up, resume the video and I will give you the answer. So pause the video and then resume it when you're ready. Okay, for the first one you should have gotten 16. The second one you should have gotten 3. Number 3 you should have gotten 9. 4 you should have gotten 54 miles. This one was 9 students. 5 would have been 86 cars. And then the last one would have been D. You guys need to make sure that you write this objective in your notes. So you're going to be finding the constant rate of change by using a table and a graph. So it's stuff that you've already learned. It should be just a good review. And then you guys will be having a quiz next week. So make sure you're taking notes so that way the quiz, you're ready for the quiz. Okay. Rate of change and constant rate of change, we've already talked about. They should be in your notes, except we are strictly looking at the table and we're looking at it a different way. So instead of finding the unit rate like we were doing, we are doing it the way that we had already showed you. So it's just more practice to make sure you're understanding. Okay, so if you need to look at these again, make sure that these are in your notes. So the rate of change describes how one quantity changes in relation to the other, so that's the change in x over the change in y. And then anytime you have a linear relationship, there will be a constant rate of change. So meaning it's happening the same way, so our slope is going to be the same, and we'll talk about that later on in the lesson. Anytime you need to pause the video to make sure you're getting all the notes down, and then resume it whenever you guys are ready. So looking at this first one, the table shows that the miles that Claire drove on a trip. Use the information to find the constant rate of change in miles per hour. So when we were talking about this, we were doing 130 divided by 2, 260 divided by 4, 390 divided by 6, and it would give us the same thing. So instead of doing that, we are going to look for patterns. So we're going to look at our change in our y and then our change in our x. Okay, so if I'm looking at this will be my y, this will be my x. So looking at my change, I'm adding 130 here each time. So I could try to say right off the bat that it's going to be linear. Okay, my change in y, I'm adding 2 each time. Okay, so yes, this looks linear, but just to double check and just to make sure, I'm going to have you guys take it backwards as well, because don't forget a linear relationship has to go to 0, 0. So instead of adding 2, if I added 2 here, what plus 2 would give me 2 would be 0. And then what plus 130 would give me 130. So that would also be 0. So make sure that you have a 0, 0 before you continue anywhere else. So it will say that you're going to find the constant rate of change, so you should know that it's linear, but I still want you to make sure that you are getting this correctly. So my change in y is, oh, I'm sorry, I put that wrong. They mixed me up. So this is y, this is x. Okay, time is usually x. They don't normally put them backwards, but they did this time. So 130 over 2, or if I were to simplify that, what would you get? Talk to a table mate really quickly. You should have gotten 65. Okay, so every hour that I travel, I'm going 65 miles per hour. Okay, so 65 miles per hour, and that's my constant rate of change or my slope. So you need to know that vocabulary word, that constant rate of change, rate, the proportional relationship, all of those, and slope mean the same thing. Okay, so looking at this one, it's going to ask for our change in y and our change in x. So it's kind of giving us the pattern, so we're still just continuing to look. So as you see, it went plus 40, plus 40, plus 40. So just to double check, I'm going to go backwards. I would get 4 or 0, because 0 plus 40 is 40. This one is adding 5. So if I went backwards, I would get 0. So it does go through 0, 0. It is a linear line, so it's a straight line. Goes through the origin, so yes, it is proportional. And then my change of y in this one is going to be 40 over 5, which would be the same thing as 8 over 1. So you still want this unit rate, so you always want that x to be over 1. You just want to make sure that you are dividing completely through, making sure there's a pattern, making sure you're putting your variables in the right spot and not messing up like I did on the first slide. Okay? So pause the video, you do these two with the table mate, and then when you come back, I will give you the answers. So pause the video and work these ones out. Okay, welcome back. So when you are looking at this one, you're looking for the constant of change in miles per minute. So this one they did write as the X and the Y, so they wrote it correctly. So you should have gotten about 9 2/3 or 9.6 repeating miles per minute. And then, so it's going up about almost 10 and then over 1. So this is my unit rate. And then the table shows the number of students that buses can transport. This one you would have gotten 72 students per bus. So each bus can hold about 72 students. We're not going to be graphing linear lines right now, but we will be getting there eventually. Okay, so looking at this one just gives you a graph, so it's the same thing. So what I mean by slope is I'm talking about how far up it goes from my y and how far over it goes for my x. So my rise and my run. So you might want to write that in your notes, that your x is considered your run, your y is considered your rise. So my change in y is my rise, my change in x is my run. So we use those to kind of let us know. So if I'm looking at this graph, my rise, it rose 60. Okay, so 60 miles. So that's my rise. It went over 1. So 60 over 1. So that is my slope in this case, or my constant rate of change. But what's so neat about a linear line is every time this should be the case. I go up 60, I go over 1. I go up 60, I go over 1. And that's going to continue forever because a line is never ending. Okay, so if you look here, you know this is your x and this is your y. So if you can't really tell on the graph, my y is 60, my x is 1. So you can still do the same thing. This one, this is my y, this is my x. So I can do 120 over 2. If I divide that out, I still get 60 over 1. So these are all proportional relationships. They all end up being the same, except I would like you guys to start knowing that instead of just a constant rate of change, this is your slope. It'll be hit really big into 8th grade, and it's just a good term to know. So slope and constant rate of change mean the same exact thing, but make sure you have them both in your notes. Okay, so explain what the ordered pairs 0, 0, and 160 represent. So this is the same exact thing we've already done. So 0, 0 represents that there was no hours, no miles. So if I go 0 hours, I traveled 0 miles. Okay, 160 represents 1 hour, because that's on my x, and 60 miles. So you just have to be able to interpret where your x is, where your y is, and then what the labels mean. So it's going to give everything to you. All you have to do is just write them down in words what they mean. So this is all you would have to do for this problem. Okay, pause the video. You guys complete this one, and then when you come back, I will give you the answers. So pause the video, complete this, and then we'll talk about it. Okay, welcome back. So use the graph to find the constant rate of change. So you should have done that first. So you're looking at how far up and how far over you go. So if you look at the difference between your y's, it's going to be 300. And then if you look at the difference between your x's, it's only going to be 1. So every 300 miles is an hour. So when the plane is flying, that would make sense. So 300 miles per hour. So 0, 0 would represent 0 hours, 0 miles. And then 1, 300 would represent 1 hour, 300 miles. Okay, so again, you're just picking apart the pieces. There is a formula that you can use to use this, but you won't see it a lot. If you want to write it down, it's your y2 minus your y1 over x2 minus x1. All that means is you are choosing 2 y values. So I can choose this y value and this y value and plug it in. So 600 minus 300, and that's what gave me this 300, okay? And then I can choose 2 x values, so 2 minus 1, and that's what gave me my 1. So it doesn't matter which 2 points you use as long as you're using the same x and y of those points. So this might be something good to write down as a reference because you might see it on pause, but it's not something that you're going to be tested on. So I'll leave that up to you guys. Okay, I would like you guys to complete this one, and then when you come back, I will give you the answers. So pause the video and complete this. Okay, welcome back. Use the graph to find the constant rate of change in miles per hour while driving in the city. So it already tells you right here in a unit rate that it's 30 miles per 1 hour. So you shouldn't have had to do any rate of change, but if you were to, you could have done 60 minus 30 and got 30. So you went up 30 over 1, that's fine. So you needed to have 30 miles per hour. And then for 0, 0, 0 hours, 0 miles, and then 130 is 1 hour, 30 miles. So that should be pretty straightforward, pretty easy. Okay, this one, you're comparing two things. So this first one I'm looking at, I have to find my rise over my run. So I went from 8 to 16, so this is 8. And I went over from 1 to 2, so this is 1. So my y over x would be 8 over 1. This one is plus 12. So the pedals actually costs more per bike. Okay, so this is going to be my more expensive one because they're charging $12 per hour. This one's only charging $8 per hour. So you're getting the better deal with Super Cycles. So you just have to be able to look and put them both together and compare. Pause the video and you guys try this one. And then when you come back, I will give you the answers. So pause the video. Okay, looking at this one, you should have had plus 15 each time. Oh, this one did not end up being a proportional relationship. So that is not going to work. I don't know why they chose those numbers, but that's okay. So we're just going to pretend for a second. Okay, this one is up 10 over 1, up 10 over 1. So this one is $10 per hour. I'm thinking this one should have been 15, so this one probably should have jumped up to 60, but it didn't. So this one is going to charge less per hour in this case. So the sweepers are us. Okay, pause the video. You need to complete this on an exit ticket. When you're finished, you can have your homework. Make sure you're using your time wisely. I will not be accepting homework after Friday, so there's your heads up now that I would get busy on it. Otherwise, they're all going to go in as zeros. So you already only have 3 homework assignments that were due for me, plus the couple when I was gone. So get busy on those. Have a fabulous day, and I will see you all tomorrow.